Now we're going to look at some improper integrals. Now we have two basic type of improper integrals. One has an infinite limit, either on top or on bottom or on both. And these are definite integrals. So we are measuring some sort of area that's open-ended on one side. It's an infinite area. Okay, and in the other case we have an integrand that has a vertical asymptote. So this one that we're looking at here, 1 over the square root of x, has a vertical asymptote when x is equal to 0. So this integral represents the area from 0 to 1 under this curve. So it's also an open-ended area. This time the open part goes up, is on top, and here it's on the right. Okay, so these are two types of improper integrals. And we'll see how to handle these. So let's start with our first example. All right, our first example is of the second type. This integrand has a vertical asymptote at x equals 3. All right, so what we were doing to integrate this, we replace the problem point. Like here, the problem point is x equals 3. We replace that with r. And we'll take the limit as r goes to 3. All right, so let's integrate this. So this is x minus 3 to the 1/2 divided by 1/2 or times 2. And we're going to evaluate this between r and 4, and we'll take the limit as r goes to 3. So just writing this out, we have limit r goes to 3 to 4 minus 3 to the 1/2 minus 2 r minus 3 to the 1/2. Okay, so we just substituted in. 4 minus 3 is 1. So this is 2 times 1 over here. And here, as r goes to 3, this goes to 0. So when we take the limit, we just get 2. All right, so we say that this open-ended area is in fact finite, and the integrand converges. Let's do another example. This is of the same type. We have a vertical asymptote at 1, so this is the problem point. All right, so this one is very similar to the previous one. We'll put an r over here. And let's integrate. So here we have x minus 1. We're going to add 5/5 as x minus 1 to the 3/5. Divide by 3/5 or multiply by 5/3. And do the substituting. Substitute r. And now substitute 0. Okay, now what do we have here? Here, this is 0 minus 1. This is minus 1 to the 3/5, which is minus 1. And here, as r goes to 1, this goes to 0. Okay, so this whole thing is going to 0. So here we have minus 5/3, which is 5/3. So because this is finite, our integral converges. Okay, so far we have 2 examples that converge. Okay, let's look at the next one. 20. Okay, sorry, excuse me, this is a 3 here. Sorry, this is a 1 here. Okay, another vertical asymptote. Here we go. Here's the problem point. 1 makes this denominator 0. So let's proceed in the same way we did before. And we'll integrate. Okay, so here add 1, we get x minus 1 to the minus 2, and divide by minus 2. And we'll substitute in now. Okay, I'm going to write it like this. I'll write this in the denominator. And then we have minus a minus, so that's plus. Okay, we substitute in 0 over here. All right, here we're going to take the limit as r goes to infinity. Sorry, that's the limit as r goes to, I wrote r goes to infinity. It's the limit as r goes to 1. Okay, this integrand has a vertical asymptote at x equal 1, and one of our limits is 1. So we're going to replace that limit with r and take the limit as r goes to 1. Okay, and here we have x minus 1 to the minus 3 dx. So now let's integrate. All right, just do the power rule. And we're going to evaluate this. Okay, let's first substitute in r. And now let's subtract and substitute in 0. So we're subtracting a minus, so I'm going to put a plus here. All right, now let's take the limit as r goes to 1. Well, as r goes to 1, this denominator is going to 0. So this quantity is going to infinity. All right, so that makes this integral diverge. It doesn't go to a finite value. So this diverges. Number 21, this infinite limit makes this an improper integral. All right, we integrate this by integration by parts. And for dv, we're going to choose e to the minus x. That's our dv. Let me make a little more room here. Okay, so here, dv is e to the minus x dx. Okay, integrating both sides, we have v is equal to minus e to the minus x. All right, now we'll do a little formula uv minus v du. So here we have uv is x, e to the, so that's minus x e to the minus x, minus v du. So we have minus, so that'll be plus the integral of e to the minus x dx. Okay, now we're going to evaluate this. Gets evaluated between 0 and infinity. We'll say 0 and r. And we'll take the limit as r goes to infinity. And here we're also evaluating between 0 and r. All right, so let's go ahead and finish the integration. Okay, integrating this, we have minus e to the minus x. I'll write that as 1 over e to the x. Okay, now what happens when r goes to infinity? Well, okay, first we'll substitute in r and then see what happens. Let's do that. Okay, so we're going to substitute in r. Minus x, I'll write minus r. E to the minus r, I'll put that in the denominator as e to the r. Minus 1 over e to the r. And now we could substitute in 0, subtract. When we substitute in 0 here, we get 0 minus 1 over e to the 0. So that would be 1 over 1. So I'll do 0 minus 1 here. All right, now let's look at this. As r goes to infinity, this goes to 0 because the denominator is going to infinity. So this is going to 0. Now here, the top is going to infinity, r goes to infinity, and the denominator also is going to infinity. But we can show by L'Hopital's rule, this is a limit of the form infinity over infinity, and we can show by L'Hopital's rule that this is going to go to 0. Let me just show it down here. We'll do r over e to the r. Okay, the limit. Okay, and then this is infinity over infinity. So we can use L'Hopital's. So this is equal to the limit as r goes to infinity of derivative of the top is 1 and the derivative of the bottom is e to the r, and that's equal to 0. So this goes to 0. The first set of brackets both go to 0, both terms, and here we have minus minus 1, which is 1. So this integral converges, and it converges to 1. Here's another improper integral. We have an infinite limit. That makes it improper. Okay, so let's write this as limit r goes to infinity. And integrate. And we're going to evaluate between 1 and r. Okay, so let's do that. So we have 1 over minus 2 times 1 over r squared plus 1 over 2. And we're taking the limit here as r goes to infinity. Okay, so this is going to 0. The first term goes to 0 because this denominator is going to infinity. So this is equal to 1/2. So we have a convergent integral.